Now let's look at example 5. We want to find the probabilities indicated, all for a standard normal curve. We want the probability that z is greater than 1.6 and the probability that z is greater than negative 1.02. Now remember in example 4, we found that when we used Excel, it gave us the probability that z was less than a number. All right, so we're going to do the same thing that we did in example 4, but we have to do an extra calculation to get greater than. All right, so first, I'm going to go to Excel, and we're going to look at z being greater than 1.6. All right, so I'm going to use that same command we used before, norm.s.dist, and I'm going to put my, 1.60 in there, and true. And it gives me 0.945201. Now recall that this is the area to the left of, or this is the z value less than 1.60. This is the probability that we're less than. Now remember though that the normal curve has an area of 1 underneath it. So if we want to get greater than, all we need to do is subtract 1 minus 0.945201, and that is going to give us the probability that we need for a greater than problem, which in this instance is 0.054799. All right, now let's do the same thing for our second one. Let's notice also that our second one was z greater than negative 1.02. So we're going to do the same thing. We're going to put it into Excel, negative 1.02. So equals norm.s.dist, negative 1.02, true. But since this is actually the probability that it's less than negative 1.02, we want to subtract this probability from 1. And this gives us 0.846136 as our probability answer.